Welcome back to the Irish Haematology Oncology podcast. This is Eoin Tabb, continuing our daily dispatches from the ISOPP CAPhO 2025 Symposium in Victoria, Canada. This episode covers the highlights from day 3, and that's Saturday, the 5th of April. If you haven't, do check out the recaps from day 1 and day 2. Day 3 offered another compelling mix of sessions. We started with a vital plenary on equity, diversity, and inclusion in our profession. And this was followed by fascinating updates on pre-therapeutic pharmacogenomic testing, preventing cancer-associated thrombosis, and the rapidly evolving world of artificial intelligence in oncology. I have some exciting news from the ISOPP AGM to share towards the end of this episode, so please do listen to the end. Let's dive into the key discussions from day 3. The day featured a crucial plenary session titled Unpacking Equity, Diversity and Inclusion, or EDI, why it matters, what the research says, and how ISOPP can drive change. It was presented by 3 speakers, Afomia Gebra, sorry about the pronunciations here, Jurga McLean and Jennifer Jupp. Afomia began by defining the core concepts. So diversity, it's embracing differences. Equity is fair treatment and equal opportunities, distinct from equality, which gives everyone the same thing regardless of need. And inclusion, creating a culture where all voices are respected and encouraged. She also covered health equity, addressing barriers like racism, sexism, poverty, and the role of implicit bias. So those unconscious attitudes that you have and how they can lead to the social determinants of health in creating measurable health inequities. So examples of health inequities in cancer care were discussed, such as delayed diagnosis or misdiagnosis of skin toxicities in patients with skin of color due to lack of representative images and appropriate terminology in resources. So erythema for reddening of the skin does not apply in people of color and may come as a different presentation. The historical context of discrimination in healthcare was also touched upon, reminding us that these issues have deep roots. The importance of EDI was stressed not just for patients, so better outcomes, reduced inequities, improved experience, but also for creating safer, more supportive workplaces for colleagues from diverse backgrounds. Actionable steps for individuals included self-education on biases, seeking training and learning how to challenge non-inclusive behaviours. Jurga McLean then shared insights from recent research conducted by the British Oncology Pharmacy Association, their EDI subcommittee. Their survey of UK oncology pharmacy professionals revealed concerning findings. 41% reported experiencing microaggressions, bullying or discrimination, most commonly related to race and ethnicity. While many agreed their leadership aimed for fairness, fewer felt internal promotion processes were fair, and a significant portion lacked confidence in challenging inappropriate behaviour. The survey highlighted a demand for training on creating inclusive environments for patients from diverse ethnic, racial backgrounds, LGBTQ plus individuals, neurodiverse individuals, and those with physical disabilities. Jurga also introduced BOPA's work developing inclusive counselling checklists using a Delphi consensus method, covering areas like physical well-being, communication strategies, accessibility to care, emotional supports, cultural and religious needs of specific patient groups, and just, I suppose, the needs in general of certain groups like older adults, minority ethnic groups, physical disabilities, and that neurodiverse population. Finally, Jennifer Jupp outlined ISOPP's own EDI initiatives. So an EDI task force with global representation was formed last year, leading to an ISOPP position statement on EDI and a Symposium presenter guide checklist. So ISOPP is working to embed EDI principles across its committees and activities using the FAIR acronym: fairness, access, inclusion, representation. Future directions include defining clear criteria for awards and grants, ensuring diverse representation, offering bias training, examining EDI-related barriers to participation, and supporting the research mentorship program. The overarching message was that EDI is everyone's business and integral to advancing oncology pharmacy practice globally. Really important considering the global landscape and what's going on at the moment. So then I went on to the next session. So Scott Nelson from Vanderbilt University Medical Center provided a balanced perspective on AI in oncology, weighing the benefits and mitigating risks. He outlined current and potential AI applications in oncology, so diagnostics, image analysis, drug discovery, personalizing treatment plans, predictive analysis, so risk prediction was going on there, optimizing supply chains and streamlining administrative tasks like prior authorizations or clinical verification of prescriptions, I suppose we call it. Benefits include excellent pattern recognition, potentially improving efficiency, reducing costs, and improving patient outcomes. However, he cautioned against unchecked enthusiasm, stressing the need for rigorous clinical validation, treating AI as a software as a medical device, and careful implementation. He recounted the story of IBM Watson's struggle in healthcare, highlighting the mismatch between machine learning and clinical workflows and the difficulty in proving real-world value. A major focus was on the side effects or risks of AI. Hallucinations are one thing, so AI models generating plausible but incorrect or fabricated information. Examples, fake drug names. He gave an example of a paper that was developed by AI, which totally fabricated the name of etanerfigig or something, which was just something that the AI had made up. And also doing non-existent citations. So in a research paper, the citations at the end were totally fabricated as well. Another risk was jailbreaking, so manipulating AI to bypass safety constraints. So by telling a lie to the AI and saying that, oh no, it's okay, it might actually allow you to do things that you shouldn't be allowed to do. Bias, so AI models can inherit and amplify biases present in the data they are trained on. So the garbage that goes into a model is the garbage you'll get out of the model, and that can potentially worsen health inequities. There's automation bias as well, over-reliance on AI recommendations without critical human appraisal, leading to errors of commission, so accepting wrong advice, or omission, failing to act without AI prompting. So being over-reliant on it. And he also spoke about model drift. So this is where the AI model performance degrades over time as clinical practice, patient populations, or data inputs change, necessitating ongoing monitoring and re-establishing of new models every now and again. Because the more bad data, they're brilliant when they're set up initially, but the more bad data that gets entered into AI, it gets trained on that bad data. So they actually perform worse as time goes on, and they need to be rebooted or validated. Other challenges as well was healthcare complexity, implementation hurdles, privacy and security around these models, transparency as to where that data is being held, cost and ethical considerations as well. Specific applications like large language models, so your ChatGPT, Google Gemini and stuff, for drafting patient messages show promise for efficiency, but they require careful human oversight, putting the human in the loop, in the AI loop, to ensure accuracy and safety. Ambient scribes, AI listening, and drafting notes have shown mixed results on reducing documentation burden and burnout. However, he did say, even though it showed that mixed results, that participants were more favorable towards the AI usage because they were no longer drafting the notes themselves. They were only editing notes that the AI scribes had done, and thereby found that an easier process. The key message was to embrace AI as augmented intelligence, so augmenting your own intelligence, focusing on the synergy between human clinicians and AI tools rather than the replacements. Pharmacists need to educate themselves about AI, participate in pilot programs, use tools critically, and contribute to ensuring safe and effective implementation. The question asked, will AI replace pharmacists? The resounding answer was no, but a pharmacist using AI will replace a pharmacist not using AI. Then I went on to another presentation. There was Hadley Bortz, who is an anticoagulation stewardship pharmacist from Australia, presented preventing a catastrophe, cancer-associated thrombosis, and he had plenty of cat-related puns and memes throughout his presentation, which was great. So he started by emphasizing the significant burden of cancer-associated thrombosis, or VTE, in cancer patients. It's a leading complication contributing to morbidity, mortality, and healthcare costs, with around 80% of cases occurring in ambulatory patients. Cancer patients have a 4 to 7 times higher risk of VTE than the general population, with risks varying greatly by cancer type. The highest for pancreas, stomach, brain, and lung. There was risks for the staging, the treatment, so chemo, angiogenics, IMiDs in the hematology sphere, and patient factors, so age, obesity, immobility, and a previous history of VTE. Despite this high risk, the uptake of guideline-recommended thromboprophylaxis for eligible ambulatory or outpatient patients remains suboptimal, so less than or around 25%. Guidelines recommend using validated risk assessment models to identify high-risk patients who might benefit from prophylaxis. The Corana score is the most well-known and validated risk assessment model, incorporating cancer site, platelet count, hemoglobin, leukocyte count, and patient's BMI. A score of greater than 2. It was originally greater than 3, but there was a lot of patients lost out of the loop in that scoring, so it's been refined to greater than 2. Identifies patients at higher risk, around a 9 to 11% VTE risk over a 6-month period. Other risk assessment models exist: Vienna CATS, PROTECT, OncoTev, Target TP, loads more others, which may incorporate biomarkers like D-dimer or different clinical factors, potentially offering better discrimination, but often being more complex. It still seemed to be that the Corana score was one of the main risk assessment models that is used in guideline development by all of the major players: ASCO, ESMO, NCCN. Guideline recommendations for primary VTE prevention were summarized. So for medical inpatients, routine prophylaxis, a low molecular weight heparin was recommended. For surgical patients, routine prophylaxis extending up to a 4 to 5 weeks post-op for major abdominopelvic cancer surgery with high-risk features. Again, low molecular weight heparin was preferred. ASCO did give a DOAC option. Multiple myeloma, prophylaxis indicated with IMiD combination therapy, low molecular weight heparin for higher risk, aspirin potentially for lower risk. And then for those ambulatory patients, so in general, prophylaxis is not routine, but should be considered for high-risk patients. So example, a Corana score greater than or equal to 2, or locally advanced metastatic pancreatic cancer with low bleeding risk. Options include DOACs, so apixaban, rivaroxaban, based on the Cassini and the AVERT trials, or a low molecular weight heparin. The risk-benefit should be reassessed periodically. Barriers to implementing ambulatory prophylaxis include physician hesitancy, so bleeding concerns from clinicians, difficulty defining who high-risk patients are, system constraints, who's going to do these assessments and at what stage of the workflow is that happening, and an inconsistent risk assessment model use internationally or nationally within each country. Successful implementation requires multidisciplinary approaches. Examples were shown integrating EHR-based risk assessment model calculations, something that we're missing in Ireland, and EHR. Nursing assessment workflows, patient education, specialist referral pathways, so to a hematology pharmacist, and shared decision making. So pharmacists play a critical role in identifying eligible patients, so doing those calculation risk scores during prescription checks, assessing bleeding risk, drug interactions, educating patients, developing protocols, and driving quality improvement through audit and feedback. He concluded by highlighting a global survey currently underway to benchmark practices and encourage participation. I'll drop that in the link to that in the show notes below if you want to give your insight on the Irish or international, how you undertake prophylaxis. So then I went on to Another one, which was Professor Jesse Swen from Leiden University Medical Center in the Netherlands. He gave an excellent presentation on pre-therapeutic pharmacogenomic testing to prevent adverse drug reactions. He argued compellingly for moving pharmacogenetics from a reactive approach, so testing after toxicity occurs, to a pre-therapeutic panel-based strategy. He used a well-established DPYD fluoropyrimidine interaction as a key example. Variants in the DPYD gene significantly increase the risk of severe, sometimes fatal toxicity with 5-FU or capecitabine. Therapeutic DPYD testing allows for dose adjustments, so examples of 50% dose reduction for carriers of certain variants, which studies show dramatically reduce severe toxicity rates without compromising treatment efficacy, which we have already seen in Ireland. Professor Swen introduced the work of the Dutch Pharmacogenetics Working Group, established in 2005. This working group systematically reviews literature and develops evidence-based quantitative gene drug guidelines, providing specific dose recommendations based on genotype. So depending on your genotype, what percentage of a standard dose should the patient get? These guidelines cover numerous drug gene pairs relevant to various fields, including oncology, but it was pan-therapeutic. It was across all different therapeutic classes. So examples he had were DPYD, UGT1A1, and TPMT. He highlighted that actionable pharmacogenetics variants are incredibly common. Studies show over 95% of individuals carry at least one variant that could affect their response to common medications. This supports the rationale for pre-therapeutic panel testing rather than single gene tests. Sarah Glewis from the Peter MacCallum Cancer Centre in Australia presented on using pharmacogenetics and therapeutic drug monitoring to address under and overdosing with 5-FU. She started by reinforcing the problem. Standard BSA-based dosing for 5-FU and capecitabine results in massive variability in drug exposure, with estimates suggesting that 40 to 60% of patients are underdosed and 10 to 20% are overdosed. While DPYD genotyping helps identify patients at high risk of severe toxicity, those poor metabolizers or needing initial dose reductions, intermediate metabolizers, it doesn't account for all the variability. This is where therapeutic drug monitoring comes in. Therapeutic drug monitoring involves measuring drug concentrations to guide dosing, so similar to your vancomycin, aiming for a target 5-FU AUC of 20 to 30. And that's recommended for optimal efficacy and reduced toxicity. Evidence supports therapeutic drug monitoring in reducing exposure variability, improving survival outcomes, especially in advanced colorectal and head and neck cancers, and improving tolerability, reduced diarrhea, and hand-foot syndrome. However, barriers like sample collection logistics, requiring extra patient visits for timed blood draws and specific sample handling, have limited routine therapeutic drug monitoring use. Sarah presented results from the Australian PREDICT 5-FU trial. It's a multi-centre study assessing the feasibility of implementing a routine 5-FU therapeutic drug monitoring service alongside the DPYD genotyping. So those two are running side by side, that you're genotyping the patient for their DPYD genotype, and then you're doing a therapeutic drug monitoring of the given 5-FU dose and altering the dose base to try and hit that target AUC of 20 to 30. The trial successfully demonstrated feasibility, with 95% of patients completing TDM sampling and results returned within a mean of 4 days. Crucially, baseline AUCs based on BSA dosing were highly variable, with only 22% of patients within that target range. So the recommendations for genotyping now, depending on what genotype of DPYD variant that you have, the recommendations could be 50% for cycle 1, 75% for cycle 2, 85% for cycle 3, and all the different variations. But with those guidelines in place, only 22% of patients still hit that target range. So after therapeutic Drug Monitoring guided dose adjustments using a validated algorithm, the proportions of patients achieving the target AUC significantly increased or doubled to 44%. The study also highlighted a perception gap, as most clinicians and patients initially believed BSA dosing was adequate even when AUC levels were suboptimal. Importantly, the trial showed how therapeutic drug monitoring could be used to safely dose escalate DPYD intermediate metabolizers who received that initial 50% dose reduction based on the pharmacogenetics. EDM allowed titration back towards the target AAC, potentially mitigating concerns about underdosing and reduced efficacy in these patients. The trial also explored fingerprint sampling for TDM, which showed promise for convenience, but needs further validation due to the observed bias compared to plasma levels. One really interesting point from it as well was that there was one patient who actually got a 112% dose of 5FU based on that therapeutic drug monitoring. So that actually their 100% dose of 5FU was suboptimal based on those AUC scores, and that they actually were bumped above the 100% level. The ongoing Precision ITS trial in Australia is further investigating a combined pharmacogenetics and therapeutic drug monitoring approach for metastatic colorectal cancer, including the feasibility of patient self-collection of fingerprint samples at home, aiming to overcome logistical barriers. The pharmacist's role was central throughout these studies: screening, consenting, coordinating samples, interpreting results, calculating doses, counselling, and follow-up. The conclusion is that combining upfront DPYD pharmacogenetics with a subsequent therapeutic drug monitoring appears feasible and helps optimize 5FU dosing for both safety and efficacy. Before we get to the key takeaways, I wanted to share some exciting developments from the ISOPP annual general meeting and a global leaders meeting I attended here at the conference. And firstly, the big news from the AGM is the location and format for next year's ISOPP Symposium. Get ready for something quite different. It's going to be a 24-hour continuous virtual conference designed to be accessible across all time zones. And I'm absolutely thrilled to announce that the Irish Pharmacy Haematology Oncology Society, IPHOS, will be collaborating closely with ISOPP on this, contributing about 6 hours of dedicated content to the programme. This is a massive opportunity for Irish haematology and oncology pharmacy to showcase our work on a global stage. The logistics are still being finalised, but it promises to be an innovative and truly international event. Watch this space for more details. Both myself and IPHOS will be looking for a huge amount of help and input from our members in Ireland to make this ambitious project a success. Secondly, I participated in an ISOPP Global Leaders meeting. This brought together representatives from numerous countries and was an incredible opportunity to build connections and establish a strong global network of oncology pharmacists. It really highlighted the shared challenges and opportunities we face worldwide in terms of burnout, drug shortages, staffing levels, how we educate one another. I suppose this leads me to strongly encourage anyone listening who isn't already involved with ISOPP to consider joining. It's a fantastic organisation that offers invaluable avenues for professional development, whether through research collaborations, accessing educational resources, contributing to guideline development and endorsement, or getting support with publications. The networking opportunities alone, as demonstrated by that global leaders meeting, are incredibly valuable for broadening perspectives and advancing your career. Definitely check out the ISOPP website for more information, and it's free membership to join. They've just redone their website, so it's much easier to access. There's a discussion forum on it that you can access, lots of different resources, and they host webinars constantly on it. So it's a fantastic education resource, and definitely encourage you to get involved. So, summarizing the key learning points from a PAC Day 3, upfront EDI, equity, diversity, and inclusion are crucial for both patients and staff. Addressing implicit bias, promoting cultural humility, and implementing inclusive practices are essential for equitable cancer care. Organizations like BOPA and ISOPP are actively working in this space. AI in oncology. AI offers potential benefits but carries significant risks: hallucinations, bias, model drift. A cautious, evidence-based approach focusing on augmented intelligence with human oversight and continuous monitoring or algorithmovigilance is essential for safe implementation. Cancer-associated thrombosis, so CAT prevention in high-risk ambulatory patients, is underutilized. Risk assessment models, especially the Corona score greater or equal to 2, help identify candidates for prophylaxis. Pharmacist-led multidisciplinary programs are vital to bridge the evidence practice gap. Pharmacogenomics, so pre-therapeutic pharmacogenomic panel testing, like the 12-gene panel in that PREPARE study, is feasible and clinically effective, significantly reducing ADR risk. Guidelines like that Dutch Pharmacogenetics Working Group support implementation, and pharmacists are key players in this space. Great work has already been done by the NCCP in this space. Then we went on to the Pharmacogenetics and Therapeutic Drug Monitoring, that 5FU study. So combining upfront DPYD genotyping and subsequent therapeutic drug monitoring helps optimize 5FU capecitabine dosing, reducing toxicity risk while enabling safe dose titration, particularly for DPYD intermediate metabolizers. Pharmacists are central to implementing this combined approach. And lastly, the ISOPP future. Exciting developments include a novel 24-hour virtual symposium next year with significant Irish involvement and strengthening global networks to advance oncology pharmacy practice worldwide. Getting involved offers great opportunities. And that brings me to the end of day 3's recap from ISOPP CAPhO 2025. I didn't think I'd get this one done today. From the societal importance of EDI to the cutting edge of pharmacogenomics, therapeutic drug monitoring, and AI, alongside practical updates on thrombosis, it's been another fantastic day. I hope you've enjoyed these daily insights. Thanks to everyone who's shared it on my LinkedIn. I haven't been able to put it up elsewhere yet, but hopefully I'll get it up and you'll be able to listen to it. I'll be back with one final dispatch tomorrow covering the last day of the main symposium. Don't think it will be as long. As always, feel free to reach out with questions or comments via Spotify, Instagram, at Irish Heme Onc Pod, or email the Irish Heme Onc Podcast at gmail.com. Thank you for listening to this special ISOPP dispatch episode of the Irish Haematology Oncology Podcast. I'm going to read out the disclaimer. I'm not going to forget it today. This podcast is for educational purposes only and reflects summaries of presentations attended at ISOPP 2025. The work on this podcast has not been reviewed or endorsed by ISOPP or CAPhO. The field of cancer care is constantly advancing. Always consult with your own clinical team and refer to local institutional guidelines and trusted national resources for the most up-to-date recommendations and personalized guidance. Until tomorrow, thanks a million. See you guys.